In this video, I'm going to show you how to build a stack a third way using a linked list. So the way linked lists work is you have a series of nodes that have pointers to each other, and each node usually only contains maybe like one piece of information. So the way that we can build a stack out of these nodes is we can make a node that just contains, for instance, a single letter and a pointer to the next node further down in the stack. And then our stack will just have a pointer to the node that is on top. And we can keep adding new nodes on top when we need to push things on, and we can pop them off in the same way. Okay, so what I'm going to do is I'm going to code this all from scratch with you, and we will make some shortcuts. I'm not going to be checking, if they're popping from an empty list and things like that. That's code that you are welcome to add in your own versions of linked lists and things like that. I'm just going to do the bare bones version. Okay, so I have two files. I have a stack and a main.cpp. And what I'm going to do is in my main one, I'm just going to include IOStream because it's useful to be able to see output. And I'm also going to include my stack.h. Okay, and what I want is I want a main function. And what do I want to do with this stack? Well, let's just make a non-templated, let's keep a simple stack that holds just characters. And so I can say s.push, I don't know, an A. And then what I want to do is I want to see out s.top. So I want to see what's on top of the stack, which should be an A. And then I want to output a end line. And then what I want to do is to prove to you that it's a stack, let's push a B, and after you press a B, there should be a B on the top. And then what I'm going to do is I'm going to call pop, which should remove the top thing on the stack. And so when I call top, it should be an A again. Okay, and the way that I would compile this code is I say g++ hyphen wall hyphen std equals c++ 17. And I want to compile my main.cpp. And of course, it's going to crash because it's going like, stack hasn't been declared. Okay, well, we need to actually write our stack class. So over here, we need to write our stack class. So class stack, and don't forget the close semicolon. Okay, now how do we define a stack? Well, let's make it private. And inside my stack, I want to make a variable called top. Now this is going to point at a node. It's going to be specifically a pointer to a node. That's going to be the node that's on top. And so I'll just say this is equal to null pointer for now. Now the code is compiling because it's going to say, hey, the node hasn't been declared. So let's go and make our node first. So class node, and put the semicolon there. And every part of this, we're just going to make public just to make it easier to work with. And what's our public going to be? Our public is going to have two things in there. It's going to have a character, because we're making all our stacks are just stacks of chars here. You can make all of these templated and things like that if you like later. Okay, so we have our character, and I'm going to call this, I don't know, letter. Actually, no, let's call it letter. Okay, and it's and then I also want, once again, these nodes will point to each other, so I want to make a node pointer called down. And this is going to be, each node is going to point downwards at the node beneath it. And then I also want a constructor, and I'm just going to define all of my constructors inline to make life easier. Let's say my node takes a character named C, and what it does is I'm going to use a initialization list here, and I'm going to say the letter is going to be initialized with a C, and the down is going to be initialized with a null pointer. And I think that's actually all I need for my node. It's pretty simple. It only has two parts and a constructor. Okay, so in my stack, I need some public member functions. So probably the first one is probably the constructor. So I'm going to make a stack and it's going to have just a default empty constructor. So when I build a stack, its top is just going to point at the null pointer. Okay, not too much going on there. Now, if I look back at my main, I need to handle push, pop, and if I save my file and I run my code, now it's complaining about like push and pop and top don't exist. So let's make all of those. So let's do them in order. So the first one I have here is push. So how should push work? So it's a void function. It doesn't return anything. It does a push and it takes a character. Let's call it C here. Okay, so what does push do? Well, push's job is to make a new node and make top point at that. Okay, well that's not too hard to do. So let's make a new node. So I want a node pointer. I'm going to call it new top. And it's going to be a new node. Note, I'm dynamically allocating it because I want to make these nodes exist after this function is done. I don't want it to be deleted. I don't want it to be deconstructed. So I make a new node, and I want it to have the value C. So once again, I did dynamic allocation here because if I didn't say new here, the node that was constructed here would just get deleted right here. It would get deconstructed right there. So I want to make sure to dynamically allocate it so it doesn't get deconstructed. Okay, so I have my new top, my new node right there. Now what do I want to do with that? Well, I want to make, I need to also make sure that this new node, its down attribute, so new top, it's down. So once again, I'm reaching into the pointer inside my new top. And I want to say this is equal to the old top. So I want the node that I've just constructed, it to point at the old top. Now, it just so happens that if it's the first push, the old top is the null pointer. So the new top's down will be the null pointer. That's not a problem. But by saying this, I'm making sure that my new top, it points at my old top. Even if that's the null pointer, but if it's not the null pointer, then it'll point at whatever it actually is. Okay. And now the last and most important thing is I need to say my top is now equal to new top. Because now, after this push, my top should point at this node. And this node should point at the old top, and so forth and so forth. Okay, so let's see if this compiles. Okay, well now at least this compiled, but now it's complaining about top. So let's implement top. So what does top do? Top returns a character. It's named top. It doesn't take any arguments. And its job is to return the character at the top. Well, that's really easy because I just go to wherever my top is and say, what's the character stored in this top? So I can just say, okay, it's top. And I reach inside that, once again, using the arrow notation because top is a pointer. See, it's a pointer there. So I'm dereferencing that pointer, and I want to get at the letter. And then all I need to do is real simple. I just return that letter. All right, that's not so bad. So let's see if this compiles. Oh, wait, it compiles, and now it's complaining about pop. So let's implement pop. Pop is another void function. Doesn't return anything. Doesn't take any arguments. And its job is to get rid of the thing on the top. And the top should now point at the thing beneath the top. Okay, so I have my top. And to get at the thing beneath the top, I say down. So I dereference my top and get at the down that's inside it. And I want to save this. So I'm going to say node pointer, I'm going to call it new top, is equal to whatever the old top, whatever was beneath the old top. Okay. And then what do I want to do? Well, I need to delete this thing on top. Note that I allocated it here with new, so I better delete it somewhere. And when I pop off the thing that was put on by push, I need to delete it. So I need to say delete top pointer. Okay. And once again, this isn't an array, so we don't put the square brackets in there. We just do a normal delete this allocated object. Okay, but we're not done yet because we need to make sure that this new top is actually put in place. So we need to say, okay, now our top pointer should be new top. All right, And let's save this. Let's try compiling it. Oh, it compiles. Let's try running the executed output. And it says ABA, because when I push an A, it prints out an A. Push a B, it prints out a B. When I do a pop, it goes back to an A. So once again, this code here, now once again, this isn't templated, but this is dynamically allocated memory using a linked list, using nodes that are all linked together by pointers to the ones below.